Welcome to a quick video about the language of algebra. So today we'll cover coefficients, like terms, expressions, and equations. So to start, we'll start with a coefficient. So what is a coefficient? And it is the number factor of an algebraic term. So what does this mean? This means that the number factor, we'll start with the 4x equation just here. So if we look at this, it means a factor is another word for multiplying. So 4 is actually multiplying x in this equation. It can be written in the longhand version like this. So this means that 4 is the coefficient of x in this scenario. So then we can actually look at bigger equations like this: 4x plus 2y plus 2xy take y squared. And we can actually break it apart. So for this top one, we'll start with this first 4x to start. So 4 is the coefficient, I'll just do CE, of x. For this 2xy, 2 would be the coefficient of xy. The CE of xy. And then the last one, we've got a negative y squared, so it's still being times by something, and the way to make negative y squared still the same thing is times it by 1. So what the coefficient of this one is, it may be a little bit trickier, is we write it as negative 1 is the coefficient, sorry, I should write CE of y squared, because for y squared to become a negative y squared, it has to be times or multiplied by that negative 1 up the top. So then I'll come down to this little section here, and I'll let you just have a quick think. What is the coefficient of 3y, and what would you write for an answer? And what is the coefficient for 5x? And I'll let you write an answer. I'll continue recording in 5 seconds. So you should have had a crack at this. So the coefficient for 3y, we know that the 3 is timesing the y together to equal that expression. So 3 is the coefficient of y. And just very similarly for this one over here, 5 is the coefficient of x. So very simple, it's just the multiplying number. Then we get down to what is an expression or what is an equation. So an expression is an algebraic form consisting of numbers, variables, operations, and signs. So I'll just shorthand that for us. Algebraic form which has numbers, as in 1, 2, 3, 4, variables, such as letters x, y, z. It doesn't have to be those letters in particular. And operation signs. And have a quick think. If we think of operation, where have we heard that before? We might think of order of operations, and it's exactly the same. So that is positives, negatives, division symbols, and multiplication symbols, as well as exponents. So that is what an expression is. An equation is very, very similar. And so an equation, the only difference is it has an equal sign at the end, so it can be solved. So the technical version of that is an algebraic form with an equals sign. Very technical. So then when we look at these two things here, they are the same. They are written pretty much the same, except there's only one difference, and that is this fella here, the equals symbol. So up the top, it is an expression because we've obviously got the numbers, as in 2, 3, and 2. We've got the variables, which are the letters, the x, the y, and the y. And then we've also got the operation signs, the plus and the minus. On the bottom one, it's exactly the same. We've got the numbers, 2 and 3. We've got the variables x and y. And then we've also got the operations, plus and minus, but the only difference is that equation. So this one is an equation. This one here is an expression. So keep that in mind. And then the final one that I'd like to go over today is like terms. And this is something which is important in all algebra, and you have to get really familiar with recognizing what is a like term and what isn't. So a like term, by definition, are terms with exactly the same variable form. So in regards to this, a variable is our letter, so our x, our y, our z, could be an A if we really want, could be a B. It's just something that's replacing or substituting or mirroring what something else should be. Okay, these are variables. And for something to be a like term, so consisting of exactly the same variables, it'd have to have both x's. So if we look at this one, 2x and 2y, do they contain the same letters? No, they don't, because x and y are different. So not like terms. 2x and negative 4x, even though one is a positive number, the 2, and one is a negative number, they both have x, which is the like variable. So yes, they are. Both have x as a variable. And then the final one down the bottom, this is where I like to go through and actually highlight which ones are the like variables. And this will be important and very handy when it comes to doing particular equations where we're solving them and they've got like terms, because you can only do certain, you can only solve certain equations with like terms together. It'll make a bit more sense when we get onto that sort of section. But for example, we'll start with the negative 2x. Which other ones along this number sequence have an x in it? Obviously, it's the 4. So we'll circle them. Oopsie. And it's important to circle the operation in front of them, because that tells us whether that number is positive, such as the 4x, or negative, such as the negative 2x. So these two are like variables. And then we can move on, and we'll choose a different color. Maybe not blue, because we're already doing that. We'll do red. And then we'll start with the y's. So we circle the first one, including the operation, the addition symbol. And then we look across, and we come across another y, a negative 2y. So we have to circle that whole thing as well. So these two are like terms, and then that leaves the last two, the z's. And just like before, we have to make sure that we circle the number, the variable, and the operation. Just like that. So they're the like terms. When we get further into addition and subtraction of like terms and multiplication, this rule may come in handy. One quick example, we'll do the y's just to show you, just a bit of an idea why this is important. I like to do 2 lines to show where they're coming from. So that should be red. So we've got 6y, take away 2y. And so we just do the simple 6 take 2, which equals 4y. Nice and easy. And similarly, it goes on for the x's and also the z variables. But I'll end it here so we don't go into too much complex stuff in one short video. Thank you.